This is the Foundation Tier Magnetism revision video. There are 4 magnetic materials that you need to learn: iron, steel, cobalt, and nickel. They are the only magnetic materials that you need to be aware of. Attraction and repulsion. Attract is when opposite poles are facing each other, so you've got North Pole and a South Pole. If you've got the same poles, North and North or South and South, they repel each other. If a magnetic material is placed to near a north or south pole, it will still be attracted by either pole. There are a number of ways to view a magnetic field around a magnet. The easiest way would be placing a magnet under a sheet of paper and sprinkle iron filings on the paper to see the magnetic field. You may have done this in lessons. There is a second way of finding the magnetic field around a compass. You use a plotting compass next to a magnet. You draw a dot to show the direction of the needle is pointing, and you move the compass around the magnet, and then you join your dots up. So you should have something like this. A lot of students draw arrows as they do it. The shape of the magnetic field is pictured on the screen. It's the space where magnets feel the force. It's strongest at the poles because the lines are closest together at the poles. It always goes from north round to south, and the arrows always show the force on the north pole. Permanent or induced magnets. So magnets that make their own magnetic field are a permanent magnet. Magnets that become a magnet when placed in a magnetic field are called induced magnets. You may have done this experiment when you attach the paper clips to a magnet and then you remove the paper clips from the magnet, and the paper clips remain stuck together because they themselves are induced magnets. The right hand rule: you have to grab your pen in your right hand and place your thumb up. The direction your fingers are going in is the magnetic field, and your thumb is the current. Your pen is just pretended to be the wire. The current flows along the wire and it makes a circular magnetic field. You have to know the direction. So if it's going into the paper, as the X diagram is, this one here, you will notice your fingers will go that way. If you're coming out, place your thumb towards you in your right hand, you will notice your fingers go the opposite direction. A solenoid is a coil of wire to make the magnetic field stronger. The important thing about a solenoid is the field is strong and uniform, but you will also notice it's the same shape as the magnetic field of a bar magnet shown a minute ago. If we place an iron core or an iron nail into a solenoid, we make an electromagnet. We can test an electromagnet strength by seeing how many paper clips are picked up as we change the number of coils or change the amount of voltage. The more paper clips, the stronger the magnet is. An advantage with electromagnets is they can be switched on and off. That's the end of the magnetism video.